So what I'm going to have you write up here, rational exponents, how do I write this? Are fraction exponents. All right, I got a little semicolon there. And they represent both an integer. An integer is a nice, like a non-fraction or decimal. Nice integer exponent. And an nth root. And we'll explain what that means here in a minute. All right. All right. So now to show what that is actually telling us, put a little ex down here for an example or two. The first one I give you is 4 to the 1/2. So let's say I gave you 4 to the 1/2. And let's say I go to my calculator and I type that into the calculator. So if I did 4 and then I raise it to that power of 1/2, notice how this is going to give us a 2. All right. We know the calculator doesn't lie, right? All right. The reason that gives us a 2, all right, 4 to the 1/2 is a 2, is when you are given that fraction exponent, it, like I said, gives you an nth root and it gives you a power. So the way we can rewrite this, go ahead and draw your radical in, because it's a radical. It's a different way of expressing a radical. Whatever number is in your denominator, so in this fraction, notice how the denominator is a 2. That means that's your little index number here. So it's a square root. And then whatever number is in the numerator of this fraction, so here's the numerator of that fraction. Oops, not a 4x, that's a 4. That is the exponent of the base. So it's really a 4 to the first, but it's a square root. What do we know the square root of 4 is? 2. That's why that, when I plug it in the calculator, gave you a 2. Okay. Another example I want you to write down. Let's say I gave you 8 to the 1/3. When we write the radical, the number in your denominator, so the 3 in this case, that is your index number. So that means we're dealing with a cubed root. And then you put the 8 in the denominator or inside the radical. So you put the 8 right here, and then the numerator is the power of that 8. All right, so then it's just an 8 to the first power. So 8 to the 1/3 is the same as the cube root of 8. What do we know the cube root of 8 is? 2, right? So again, if I throw that into the calculator just to kind of prove this, 8 raised to the 1/3 power should give us a 2, because that's really just the cube root of 8 to the first. All right. All right, next one. So create some space. I'm going to have to erase a little bit. So a third one, final one, then we'll do these problems here. Do 4 to the 3/2. See if you're understanding how to rewrite that real quick. So see if you're understanding, how am I taking this and creating this, or this fraction exponent and creating this radical. So try to do that with here. This is definitely a radical, but where does the numerator go? Where does your denominator go? Thank you. All right, so we know it's a radical. Anytime you have a rational exponent, it's always a fraction. That's always going to be a radical. This is going to be inside of it. And then again, the denominator, this guy right there, that is your index number. So this is a square root. And then the numerator is your exponent. So what that really is, this is a square root of 4 times 4 times 4, which is 64. What is the square root of 64? 8. So 4 to the 3 halves, I'll show it to you on your calculator in a minute, just to kind of show that these are all equivalent. When I plug that into my calculator, promise you it's going to give us an 8. All right, so 4 to the 3 halves. All right, and then the 3 divided by the 2, and there's our 8. Okay, so rational exponents are just different way of writing radicals, and we just want to be able to translate those. That's all we're doing in these first handful of questions. So we're not going to simplify it. We're not going to break it down. We're not going to evaluate them. All I want you to do in these first handful are just write each expression in radical form. Okay, so what we hopefully are now seeing, as soon as you see a fractional power, that means it's still a radical. So you're going to do your radical right away. Whatever number is your denominator is what goes right in this little nook. All right, that's your nth root. So in this problem, that's a square root. The base is still the large number that's underneath. And then whatever the numerator is in that fraction, that is the exponent of your number. All right, so that would be a 3 to the 5th power. All right. And right now, that's all I'm having you do. All right, you're just going to leave it as the square root of 3 to the 5th. All right, so 6, same thing. Once we see a fractional power, you're going to do your radical. We know there's a 6 underneath there. The denominator of this fraction, which is a 3, that is the nth root that you're going to put right into there. So in this case, it is a cubed root. And then the numerator of the fraction, which in this case is a 4, that is the exponent of your 6. All right, got it? Simple enough. All right, do the rest of those then. Do 1 through 6 anyway, or 3 through 6. So you're just rewriting them. So every one of them is a radical, and then just what does the numerator and denominator mean in the radical? All right, Omar, what number goes in number 3? Which of those goes right here? Good. That's our denominator, so it's going to be a cubed root, and then that 5 goes into your denominator, and the exponent would then be what? Good. And then this numerator is your exponent. All right. So the next one, Lily, what number goes right here? Good. That's our 4, and then the 3 is raised to the power of what? Good, because that's our numerator. All right, Alec, what goes into the little nook here? 3, because that's our denominator, and then it's 7 to what power? 1. All right, and then our last one, Monica, what goes in our little spot here? Good, it's a square root, that's our denominator, and then it's 7 to what power? Good, and then 7 to the 5th power. Okay, that's all we're doing right now is rewriting these. All right, now let's see if we understand that. Do the opposite. So if I now have a 5th root, and it's raised to the 7th power, what would that look like if I put it as a fraction? So now rewrite this in fraction form. What would it have looked like before? All right. So not a lot of work here. What would my denominator here need to be? So now if we're going to go backwards, Assad, what does that number have to be? Good. Because that's our index number, and the numerator would have been what? Good. So that's just x to the 7/5. All right. If we go to the next one, same thing. You're going to take your 5r. That's all in a parentheses, so that's all underneath the radical. And when I now write this as a fraction power, Julia, what is the denominator of this one? Yeah, the 4 is our denominator, and what goes on top? Good. So that's 5r to the power of 7/4. All right. All right, number 9, Jada. This would be p, and then what fraction would we have? So this guy, always your denominator. So it's so it's the 5 that's the numerator and the 3 in our denominator. So the index number, always going to be your denominator. So now number 10, don't let this fool you here. So this is going to be a 2m. We want parentheses around this. Notice when we look in here, there's nothing written in there. When there's nothing written in there, it is implied to be a square root. So that means your denominator is a 2. If it's not written in, yeah, it's always a 2. And then our numerator then is a 3. So 2m to the power of 3/2. All right. Okay, do 11 and 12. Wrap those up. All right, Armando, what do you have for 11? Good. The index number is always your denominator, so that's why that's on the bottom, meaning 7 is the numerator. And then 12, Jake, what do we get? Good. 1 over a 3. So 5x is all raised to the power of 1 over a 3. All right. All right, so now, when we do these, once we do simplify them, now we're going to go all the way through, like all of these up here, like this one here. We could actually simplify this, right? Like if I actually wanted you to simplify this further, we're not going to go through with all of this. But isn't this really 3 5s? And I need squares. So I actually have 2 complete sets that I could pull out if we think about how we did this with variables. And there'd still be that 3 left over, all right, if we were to do it that way. All right, I didn't have you do that on the front page, but now when that opportunity presents itself on the back, you're going to do this. All right, so now let's see if you remember all of this. When I multiply like terms, we multiply the numbers in front. So the 2 and the 1 get multiplied together to give us a 2. And then when we multiply our n's together, so you don't change yours, but let's say I just gave you an n to the 4th times an n cubed. We'll start with a nicer one as a quick little review. What is that? N to the 12th or n to the 7th? Remember, Julia? Good. N to the 7th. Because when we multiply like terms, we actually add their exponents. So that's what's happening with these n's. So you need to do 2/3 plus a 1/3. So 2/3 plus a 1/3 is a 3/3, which is really just what? What is 3 divided by 3? Just a 1. So that answer is just a 2, and there's not much we're going to be able to do with that one. Okay, in terms of rewriting that as a radical, no radical with that. All right, 14. Do that one real quick. Same thing. Multiply the 2 and the 4, and then multiply your x's. See if you understand how to handle those exponents. If you don't know how to add fractions without a calculator, use your calculator. Know how to use the alpha y equals button to make things easy on yourselves. All right. So should do 2 times 4. That's the easy one. A lot of people are plugging this into the calculator. If you don't know how to do this without your calculator, even if you do, if you have the calculator in your hand, you might as well use it. So just a quick refresher again. So if you're not sure, if you haven't done it, what we're adding together is a 1/4 and a 2/3. So you can get to that fraction key, hit the alpha button, and then the y equals. The very first one is a numerator over a denominator. So if I hit that, notice how it pops up that fraction. And then the first one we want is just this 1/4. So I'm just doing 1/4 plus a 2/3. So I type that in, move it on over, and then we're going to add and do that all over again. So hit the alpha button, hit the Y button, and then just hit enter since number 1 is already the dark one. And then do 2/3, and then this does all the work for you. It reduces it for us, and we should get the power of 11/12. All right, we all get that? All right, so then you're going to write that as 8x to the 11/12. And then this one we now want to rewrite. So this is going to be a radical. The denominator is your index number, so this is a 12. And then the numerator is the exponent. So now understand, this is the first time we've really gone beyond 4, an index number of 4. Notice I have 11 x's inside. In order for us to pull any of them out, I would need a set of 12. Can I get a full set of 12 if I only have 11 underneath? No. So that's it. Can't do anything with that. That's our final answer. Okay? All right, 15. Some people are still writing this down. So go to 15, multiply those together. Or figure out how to simplify that. I guess it's a little bit different problem there. Okay, first things. Let me again give you a nice one first. Something that we've done before, we've quizzed on, but with some nicer numbers. So if I gave you n squared to the power of 3, this is the 3, that should give us n to the what? Remember? So if I gave you this guy, what do we think? Armando?
6.
Good. That should be the power of 6. Because what do you do with these, Armando? We multiply. So if I have a power getting raised to another power, you need to multiply. So that's what we need to do with these guys. So again, if you don't know how to do that, if you're not sure, throw it into the calculator. Multiplying fractions, though, is a lot easier, I think, than adding them. So I would think you could do that without a calculator. But if you need to use your calculator to do this, then feel free. We're just doing 3/2 multiplied by 1/2. And the reason multiplying is easier, you just multiply straight across. So 3 times 1 is 3. 2 times 2 is a 4. So that should have given us an n to the 3/4. All right. Then we want to simplify that. Go ahead and do that real quick. Rewrite that as a radical. All right, and Joe, what goes right here? Good. That's our 4, and then it would be n to the power what? Good. And then we still want to see if this goes simple any further. But if you notice, we only have 3 n's on the inside, and we would need 4 in order to pull any out. All right, so this is pretty much our answer. Can't do anything with that. All right. 16, same thing now. Go ahead and do that. See what we think here. See what n would get raised to initially. All right. Again, power to power, you multiply. So when we, again, use your calculator if you need to. You're just doing 2 times 2/3. These two guys get multiplied together. Calculator will do that for you. If not, multiplying fractions should be pretty nice. All right, 2 times 2 is going to give you a 4. The 1 and the 3 should give you a 3. So this is n to the 4/3 power. right? So that's what it is as a fraction. And then we want this to now be a cubed root of n to the fourth power. This is the first one, and again, you'll get the quiz back a little bit here with this, that we can simplify further. Because what we now have is a cubed root, and I have 4 n's inside. So if we were to pull these out, if I had a total of 4, and I need sets of 3, how many sets of 3 can I get out of 4 n's? Just one. So we're going to pull out one complete set of n's. And then how many n's would still be left over on the inside of the radical? Just one. Because we had 4, we pulled 3 of them out. So if these now start happening like we have quizzed on, if that can simplify further, we now need to remember how to simplify those further. Okay? So that final answer is n and then times the cube root of n. All right, 17. Do 17. See if you remember how to do that. Okay, let's see what we got here. So again, we'll do one that's nice first without the fractions, just as a refresher in terms of the rule. When we divide like terms, so if I had x to the 8th divided by an x cubed, when we divide like terms, that is when we subtracted their exponent. So whatever the numerator's exponent is, we subtract the denominator's exponent. So something like this would just be a simple little 8 to the 5th power, 8 minus a3. It's the same thing with 17. It's just fractions, so it's a little uglier. You may want to use a calculator. If you have it in your hand, there's no reason not to do that, just to be safe. But we're dividing like terms, so you're going to subtract these again. So it's the numerator's exponent, which is a 4/3, and then we subtract the exponent in your denominator, which is that 1/3. So same thing we did down here. This, maybe you have to use your calculator, maybe you don't, but as long as these have like denominators, can't we subtract them right off the bat? So this really should be 4 minus 1 is a 3, and then your denominator is a 3. So all of that, and we should just get an x to the power of 1, or just x. Okay? All right, last one of these, 18. Now you probably want to use your calculator. This I would strongly suggest, since now you're going to be subtracting. You have unlike denominators, unless you want to go through that process, finding a common denominator, all that good stuff. I'd use your calculator. So do that one. And again, I'll show you kind of what you're setting up. It is the numerator's exponent minus the denominator's exponent. We're just subtracting the exponents. If you want to see if you're really good, rewrite it as a radical. Finish it off. It's our last one from the notes. Rewrite it as a radical once you've done that, and then see if you can simplify that radical. Because you can't. Let's see if we got all the way through this. It's just 5/3 minus a 1/2. All right, so we'll throw that in there. 5 divided by 3. And then subtract your 1/2. And should get a 7/6. All right, I'll get that. So again, make sure you not use your calculator on that. You're going to make your life much, much easier if you know how to throw that in there. So that's the old rule. You're just doing it with fractions. And then what we've talked about today now is how can I rewrite this as a radical? So I'm going to go ahead and write that as a radical. And then Nora, what number goes in right here? Good. The 6 is your root. So that's a 6th root. And then it's a power of what? 7. And then I said that should be able to simplify a little bit further because I now have 7 ends on the inside. So it's the first time we've gone this high with our root trying to simplify one of these. But since this is now a 6th root, we basically need a set of 6 out of this in order to pull any out. Can I get a complete set of 6 if I have 7 of them? Yeah. How many sets of 6 can I get out of 7? Yeah, just one. So you're going to pull out an n. And then I'd have a 6th root still. How many of those ends would have been left over? 1 left over. Because I started with 7. I pulled out a set of 6. So there's just 1 left over. That's what our final answer would look like. Okay. So if these go any further, we need to make sure that we're following through and simplifying them like we had done a couple of quizzes ago. All right. Okay, so let me give you this. And then we'll give you the quizzes too. And you can decide if you need to do any corrections on that. Just that page, just that one page. Yep. All right. And I also have some of you who have done quiz corrections. I have some old stuff too. it all the same? Yes. Neither. Just because they're not in terms. So when you come to these, so these are both sevens. And we're going to set seven because we're going to kind of let's include one of these like that. You can't. So we really like to so a couple of different ones you can take. Ultimately, what I want you to get at is isn't this a square root? 7 to the first. This is also a square root, cube. Since those are both square roots, you can write down the square root of 7 cube. Right? And this is going to simplify a little bit. It's a square root of 2. You get 1 take 2 out of that. Okay.
Did you stop recording?
Oh, no, I did not. I'm going to show them one. Because 2 and 3 are a little sneaky. We didn't do any like that. All right, real quick, look at 2 and 3. Now that I look at these, I didn't show you any of these, and these are pretty sneaky. Because what you could do, and I want you to simplify this a little bit more. So take a peek at 2, because I doubt anybody really did this. One route you could take, my hope is everybody kind of did root 7. That's a square root of 7 to the first. And then you wrote this as a square root of a cube. So both of these have little index numbers of 7. But ideally, if we're going to be simplifying these and as much as we possibly can, as long as these are both square roots, we can go ahead and multiply these guys together so that this becomes a square root. I can do this. Of 7a cubed, because they both have that same index number of 2. So we can go ahead and multiply those guys together. Then what you have to understand is I can't do anything with the 7, but if it's a square root, how many sets of 2 can I get out of 3? I can get 1 complete set, right? So I'm going to be able to pull out one of the a's and still leave an a left over. All right. That one hopefully is not too bad. 3 is the one that's really kind of sneaky. Here's how 3 really should play out. So if you did this right now, you're not wrong. So if you wrote this as a cubed root of x to the first, and then you said this is now a 6th root of y to the 5th, that's okay. It's not wrong. You understood sort of the lesson and how to rewrite those. But ideally, we'd like to put these into one radical. And right now we can't, because one of them has a cubed root, one of them has a square root. So what we're going to do, go to the original problem here. The y to the 5, 6, I'm going to leave that alone. And what I want to do is take, let me make this nice and big. What I want to do is take this 1/3. I'd like that denominator to also be a 6. So if I'm going to make that denominator a 6, what do I multiply this denominator, this 3 by, in order to turn that into a 6? What would we do to a 3 to make it into a 6? Yeah, Joe? Multiply by 2. So in order to do that, I'm going to do the same thing to the numerator. So that you certainly have done before. You would have found common denominators and all that stuff many, many years ago. And then hopefully you understand, isn't 1/3 the same as 2/6? Doesn't that mean the same exact thing if we reduce it? So what that's now going to allow me to do, these are not like terms. So don't think you're going to multiply these and get 10/36. All right, you can only multiply like terms together and add their exponents. But now that we have this, don't they each have the same denominator of 6? So now each of those is in fact a 6th root. So we can now do this with one radical. The x has a power of 2 now because that's its numerator. And the y has a power of 5 now because that is its numerator. And then we can write that as one radical. Okay? So that one we hadn't necessarily done one exactly like that. So let's walk through that one. But that should be everybody should have that one right now. The rest I think we can do. The rest we've done at some point and should be able to handle. Okay. If you have any questions, let me know, or especially the quiz review or the quiz. If it didn't go well, you're not sure why it didn't go well. Now's you got 5 minutes or so here to ask us. Try to get that squared away to make sure you're set. Have those corrections tomorrow if you're going to do corrections though. Okay. I can stop.